Hey guys, I'm going to do something a little different this time. There's been some people making comments about wanting people to show 4X's workflows on the forums, or in the groups, I should say. So I thought I would just do a little video walkthrough of my part that I'm working on right now, just because I know there's a bit of a lack of videos showing kind of the whole walkthrough of how this all works. Hopefully mine, it's going to be relatively quick. Hopefully it shows some things maybe that the other videos kind of aren't. But, it's one of those things now that I know how it all works, maybe I too am going to skip some of the basic things that I know I didn't quite get when I was watching everyone else do it, and had to kind of figure it out on my own when I got the fourth axis, which I've only had this year. So what we're going to be doing is this little part down here. We're going to be machining these little clamp blocks. This is for the new accessory I have for the AccuBlast. It's a telescopic air blast nozzle. The tip is not attached there for some reason. So this is being offered by Mazak as a factory option, and even standalone. If they don't order a AccuBlast, they'll mount to the head, and you can have just like a fixed telescopic nozzle, just kind of like what Haas has. So we're going to be making these. So I made a tombstone, and the tombstone originally I have for making these parts, but I'm able to make these and these out of the same size stock. So this is the tombstone that I have. I've already used it to make these brackets. So these pockets here are for Op2, and then I do Op1. This is kind of showing what the stock looks like in there. It's pushed up by these pit bulls against a Sarajaw, and they work really well. These are the first parts where I realized, I've always been worried about rigidity and everything with parts when you're machining them, but I just like I see in other people's videos, you're kind of amazed when you realized how little you can hold on to things and still, get good surface finish and stuff like that. So I'm pushing these a little further now based on the fact that I know I'm usually surprised. So I'm going to try these on what I consider kind of an extreme level and try it. And if it doesn't work, then I'll just start kind of dialing it back a little bit. So I have the tombstone, obviously, and here's the origin for the tombstone, which is also going to be the work offset in the machine. So I use G58 to keep my rotary offset in. So this is the same for all of my parts and tombstones. Everything that goes on the rotary uses G58, and it's right at the center of the rotary platter. So I've got the machine modeled in here, which you don't need to have to do fourth axis. But for me, it just helps. I can roll the fourth around and check travel limits and stuff like that. This hatched box is the travel limits, so I can make sure that I'm within all the travel when I'm designing a tombstone. So it's kind of useful because my fourth isn't mounted right in the center of the table. Otherwise, it would be a lot more simple. So anyway, this is what we're gonna do. So I was gonna do a video where I, walk through making it from scratch like some people do. Well, these simple little parts have been kicking my butt for a couple days. I'm like a solid day into the cam on these things because I was having some weird issues, and like I said, I'm kind of trying to push things a little bit, so it's been a little tricky. So instead of going through it all, we'll just walk through one by one, how I'm going about doing the tool paths for these parts. And also I've got one I'm going to add, and I'll show you why I'm going to add it, and then we can just add it on video and you can see it being created from scratch. So hitting all the buttons and setting up tool orientation and all that kind of stuff. So hopefully this video, like I said, will maybe fill in some of the simple gaps that some of the other ones aren't. And I don't know, sometimes I do like watching people program parts, and sometimes it gives me ideas on how to do things. So anyway, so we'll go over to the manufacturer side. And like I said, I've already got this mostly done, and I'm also pushing it a little further than normal, but I think I've came to a spot where I think I've pushed it too far. So we're gonna add in an extra little tool path to make it a little higher probability of success, and I'll show you that in a minute. So the first thing, I'm just gonna get rid of this is just showing the stock clamped in there. We're gonna get rid of that, and then we can start walking through all the tool paths. And here. So here they are. They're inside the stock there. So the first thing we're going to do is drill these holes through, and they go all the way through the block. And I want to do that while the part is as rigid as possible. And so we're going to do it first. And we'll turn on in-process stock. So pretty simple. Now this is the first thing. And maybe I'm wrong, but I don't think I am, because I'm pretty sure I have had this exact same problem when I first started programming, where the rotary was not at 0 when I started machining a part, when I was machining it at 0. So when we've got the tombstone set up, and it's oriented just like any other part would sit in your mill. So we don't think of tool orientation when we're doing normal, 2-axis work or 2.5-axis work. So this is, it's in line. It would work. If I just picked a program like this drill, I wouldn't have had to turn on tool orientation to get it to work, because it was all oriented properly the way I wanted it to. The holes are in line with what it believes the z-axis is. So you'll have to forgive, I don't know, I'm not sure it's my computers, but Fusion to me just seems a lot slower lately. Like every time I open something, it takes a long time before I can, actually start working, which might make this video kind of painful. But anyway, like I was saying, if you had just opened a drilling cycle, it would have just let you do this with no question about it. But I turned on tool orientation, and I'd recommend you do the same, because if you don't, there's going to be no command to the rotary to go to 0 degrees to start work. So we'll get to this more in the parts where it actually matters, where we're working on a different orientation than the standard, the standard setup like any other part would be. So nothing special here. Pick the bottom bore, said the top height was the top of the stock. Nothing special. So pretty simple. So the next tool path, we're going to rough out a fair bit of the parts. And we're going to try and leave some critical areas to give it rigidity, enough rigidity to run this slitting saw through here. So this is where, again, it's like, I don't think this is pushing it at all. It's probably going to run super smooth, but in the past I would have been a little nervous. So of course it's telling me it wants to regenerate this now. But for this one is kind of interesting. I wanted to leave a couple of islands down here to hold the part, and you'll see what I mean after. But I created a sketch, and the sketch, we gotta again just kind of wait for this, but the sketch basically defined the machining boundary, and I basically wanted to go anywhere inside this green box. So I wanted to leave these basically like posts, full thickness posts holding the parts, and that was so that we could do the finishing around most of it, the slitting saw, finish the bore, stuff like that. So I created this sketch, and a lot of times we try and do things, we think CAM should be smarter and where you don't have to do this. And what I'm learning is, like, whenever you're looking to part, and right away I thought to myself, well, I should do a sketch and create a custom boundary and stuff like that. I'd recommend just do it, because you can fight around a lot trying to get it to do things automatically. This might not be a good example of that, but other times, like maybe you just need to do a patch, like put in a patch on the part or create a sketch to work from. And I think you'll be a lot less frustrated where you've got your own little workflows that you do, and it might seem like a bit of extra work, but to be honest, it just gets it to do what you want with the least amount of frustration. So nothing really special here. We're going to unfortunately have to let this regenerate, so it might take a tiny bit of time. But you'll see kind of the end result, and this is going to be, after all of these roughing operations, it's going to be prepared for the slitting. Oh, and I guess what I didn't show is tool orientation, which is mostly the point of this whole video. So we'll open that back up in a second. Because, you know, we're coming into the part from the side, basically, you know, if you want to think about it like that. Let's give it some time here. Should have maybe done this on my other computer, which is like I think a 12-core machine, which is a lot better. So this is the original origin for the tombstone, and this is, you should align this like it would sit at 0 degrees. So you want the origin of this, of your setup. This is the origin of the setup. You want it to be aligned just like it is at 0 degrees on your rotary. So when we go in and do orientation, it's going to be relative to this. And this is one of the parts I didn't fully understand when I was watching other people's videos. But anyway, so this is the rotary at 0, right? And then it's going to roll over like this for us to work on this face. So it's actually at, I mean, I forget on my machine if this is plus 90 or negative 90. I think it's negative 90 degrees. So here we go. This is what we're ending up with right now. So as you can see, of course, this is, it thinks this is on the bottom, so the lighting, I wish there's some way to change that too, but the lighting is bad. You know, it wants you to look at this side, but so we're leaving these islands of material here. It's actually quite bad, quite hard to see. That's unfortunate. But you can see those kind of islands left behind, and hopefully that's going to give us enough rigidity for the slitting saw. So the key here is tool orientation, and that's the whole magic behind programming on the 4th axis, and Fusion makes that really quite easy. So if we had just gone in here to start programming and we had picked geometry, it wouldn't have let us pick things on this face. It would want us to pick selections on the face that's like normal to Z, or however you say that. So the first thing is we need to set this. So you need to turn on tool orientation, and I think some of these are new, like this set normal or surface normal, but I've always used this select Z axis and Y axis. So basically all you have to do is, if you pick this will automatically be highlighted and ready. You need to tell it what face of it is now going to be oriented in Z. What's the new Z plane? And so this, you can tell this is the surface I selected. So it's going to rotate the rotary so that this surface is in line with the Z axis. And then it'll want you to pick X, which of course the X positive direction is on this face. That's it. The only other thing, like I said, the link I didn't quite understand is this. The origin. So it needs to know what's it comparing to. When you say this is the new Z, it needs to know the old Z in order to come up with the degrees, the move to send to the rotary. So this was old Z, this is new Z, and it's going to say, and I forget if this is positive or negative, but it's going to know, well, that's 90 degrees off. So we need to send a 90 degree command to the rotary. So it's important when you set up your work setup like this, that you properly pick the origin for the rotary when it's at 0 degrees. And of course, this isn't that. It's pointed this way when I did the setup, because this side is facing up. This is 0 degrees. So I hope that makes a bit of sense, and it doesn't feel like I'm doing a lot differently than other people, but I feel like the one big thing is the referencing what it's being compared to. When you pick this and you say, oh, this is the new Z face, you know, how does it come up with the rotary command? And that's because it's based on your origin that you set up when you created the setup for this machining or this part, basically the machining setup. So we're going to cancel this, and of course it's going to still make us wait a little bit. But now that we've roughed out the majority of this, there was a couple more operations that I did with this roughing tool, so we'll have a quick look at what those are. And then I've actually got a tool conflict in here. There's T2D3 and T2D4, so I'm gonna have to put the slitting saw in a different location. And then, yeah, I'm sorry about how hard that is to see. Maybe that's a little bit better. But so here we are. So now the next thing I did, oh yes, facing. So I obviously want to put a nice face on the part. Facing on the other side is going to be accomplished in a couple of pockets and uniforce clamps on this side of the tombstone. So I'm not going to worry. You know, if I put this in the middle, I could have maybe done like a one and done kind of part where I finish both sides and just tab it off, and there's only like a slight little burr to remove. But honestly, I'm just as happy to have a couple pockets on the tombstone and clamp them in for op 2, and it's just a little bit, maybe a little bit easier for me anyway. So then the next, yes. So this was facing the part, and then my slitting saw, this is really pushing it to get in here. So this, I needed to get rid of this extra material at the back. So that's what this operation does. So it gives me more clearance for the slitting saw to come in. Then we come in with a finishing tool, and we're going to finish from this radius around to this radius. And I'm just choosing to do that now because this is the most rigid the part will be. Once we get rid of this, it's obviously going to be a lot more flimsy. So I finished the outside, and I'm going to take this opportunity to finish the bore. And then we're going to do the slitting. And the slitting, like I said, it's back to the original orientation. So this is, you know, Z up kind of thing. So I'm just going to come in from either side. Luckily, the part's tall enough that I have clearance to get the slitting saw in here. And eventually, the idea is I'm going to have two of these parts in at the same time. So we're going to be doing this and over here. So pretty straightforward, nothing crazy. And again, I don't think there's going to be any rigidity issues here for this operation. Because these islands are still here, it should be fairly rigid. And I've also left all the back intact. So I don't think we're going to have any problems here, but I'll be listening to it and see what's going on for harmonics and stuff like that. So after that's done, then we're going to come in and we're going to do some slotting of this leftover floor material. And this is in preparation for moving towards parting these off, basically. And we're going to try and leave them with a tiny bit of material hanging on that I can just break them off with my hand. So that's that. And I'm a little worried. This one I think is going to go fairly well. And then this one starting down here, coming back up, I am worried what this is going to sound like. So we might have to try something a little different when we get to that part. And then the next thing we're going to do is with the roughing tool, we're going to get rid of these little islands down here. So if we kind of compare that to that, that's what this operation is doing. This, from experience, should go quite well. Like I said, I do those other brackets much the same way. And then, you know, we're left, basically now all that's holding on is this material here, and we're going to try and finish this wall. Sorry, and before that, we're going to take this opportunity to chamfer the part, chamfer the face. Now, this is where I think I'm going to make a small change. I think what I I'll explain what I'm going to do when we get there, but I want to take, instead of removing all this island, when I'm doing the original roughing operations and roughing the part out, I'm going to create a small, like 1 millimeter channel through here, so that when we get to this point, I'm actually going to do the chamfering before I remove the rest of these islands. So it doesn't add a tool change or anything. I'll just remove about 1 millimeter off the top of these islands to give me room to come through and chamfer them before we cut all this out. So it'll be more rigid, and I should get a nicer, cleaner chamfer on the part. I'm kind of worried. I don't think this would go very well trying to chamfer this, especially fast. Doing a rapid chamfer operation with it only hanging on like this, probably not a good recipe. So anyway, we're going to adjust that in a minute, but this was the way I originally programmed it. Chamfer's done. Then I'm going to come through with the finishing tool, and I'm going to finish, about a 0.3 millimeter stock that was left on these faces. We're going to machine those off, and hopefully that goes well and there's not a lot of chatter and we get a reasonable surface finish on here. These sides, you're not going to really see very much of them when the part is installed, but I still want them to be nice, obviously. So then after that, to avoid a tool change, I'm going to try and use the finishing tool to just slot the rest of this tab, basically, that's hanging on, and leave a very thin piece of material that will be holding the part. And the rotary is going to be in this position, and hopefully the weight of the part will bend it away while it's slotting that out. And yeah, so we're just going to try it like this. It's kind of, in my opinion, a little bit aggressive the way that I have chosen to do some of this, and we'll just see how it goes. And if it's not rigid enough for some of the things I'm doing, then we'll go back and come up with a different plan. But it's worth just trying this out and see how it goes. So like I said, what I'm going to do is I'm going to back up. Of course I can't, not that I'm aware of. I don't think I can just start making a toolpath here, although I feel like. So what we're going to do, like I said, at this point here, we're going to come and we're going to do a contour operation and just knock a millimeter slot off of here. And we want to use this roughing tool. So we want to do it right here before it switches to tool 2. So I'm going to go in, I'm just going to go 2D contour. And we're going to use, it's going to think for a few minutes here, obviously. We're going to use we're going to use that roughing tool, which is this guy. And we're going to switch to slotting. This is just my slotting recipe. And so again, so now, because this is not oriented normally, we're going to have to use tool orientation. I'll just show you, we're going to go in and we're going to try and select contours, and it's not going to be showing us, that the surfaces and stuff we want to pick. It wouldn't actually work for us. So instead, we're going to turn on tool orientation, and this is how we set it up from scratch. So remember I said, just from my experience, the easiest way to do this is to use select Z plane and X axis. And once you hit it, you can see it's already ready for you to select the Z axis, or it says Z plane. So just going to back out here just so you can see. This face here is going to be the Z axis for the work that we want to do to this part. So we're going to click that, and then it's going to want us to pick the X axis, and it's already going to be moved there for us to select. But man, this thing sure isn't happy. So it's ready for us to select X, and this is X plus. Then you can check the triad and make sure everything looks okay. So yes, this is exactly how it'll be sitting in the machine. Z is up, X plus is this way, and Y plus is that way. So this is now ready. So now when we want to come in and select our contours, we're going to do, there's probably no harm. Oh, and yeah, so Alt, hold Alt to select just line segments. If I didn't hold down Alt when I did that, it would have selected the entire path around like this. So Alt just lets you select one little segment of the part. Works on sketch lines too. And again, it's thinking. So this is correct, and we'll do the same on the other part, and then we'll program the depth, and then we'll program some stock to leave, because this is not a finishing operation. Oh boy. It's probably what's even more painful than me having to wait between every click is watching a video of somebody waiting between every click. So I apologize about that. But it's funny, if I open Task Manager, nothing is stressed out. The processor, memory, nothing's having a hard time. So I don't really know what the bottleneck is there, but it is getting a little bit annoying. So I saw some comments after the latest release where people were commenting the same thing. I'm sure typically it's a computer issue, but like I said, I mean, these computers aren't slouches, especially that 12-core machine inside. But anyway, so now we've selected these contours, and now we're going to just use this. We're going to use stock to leave. Wait for it to let me scroll down. So we're going to do this. So the radial, we're going to leave 0.3 millimeters. And then the axial, this is where we're going to pick our axial offset. I think we could have done this in the heights tab as well. We could have selected the bottom height and told it whatever we wanted. But I'm going to say we're going to go 1 millimeter. So, we're going to say -1 millimeter stock to leave, which is, of course, not very good English. But this will make the tool go down 1 millimeter lower than these contours, hopefully. So we're going to say just OK to this for now and see what it looks like. I'm not sure if this is, we might have some small issues because I picked these radius parts. We might have issues with the lead in, lead out, but we'll just see what it does first. And then if there's an issue, we can change it. So I should have pre-planned some idle chit-chat, but I didn't. So I think actually everything's okay. Now it's put this at the last operation, so that's why we're not seeing the full effect. So what we're going to do, the lead in and lead out I think is going to be okay. I just don't remember. It might plunge in to some leftover stock in this area, which might be a problem. So let's find out. Let's see what this does. So we're going to move this into the proper position. And then we're going to let it recalculate all the stock to leave. So this was where I had previously left off with the roughing tool, and now this is the new effect. So no, I don't think we've got any plunge collisions or anything like that. I think this is quite reasonable. So now we can change where our chamfer operation is. Maybe I'll want to go a bit lower, but let's find out. So there's some finishing, slotting, roughing out those tabs, then finishing that, and then the chamfer. So the chamfer now we can move actually, yeah, we'll just move it, here to right after the finishing tools. So let's see what that looks like. So we finished the outside, finished the bore, did the slotting, then we can chamfer. So yes, I think this makes sense. So as you can see, the chamfer tool is still gouging, which will make poor chamfer finish quality here. So we're gonna drop the contour down a little bit and see See how this helps until we stop getting that gouging. In-process stock, that was an awesome change in Fusion, in my opinion, to be able to just see immediately the effects of that without having to go into simulation. So what did we do? We did it in here. Oh boy. So we're gonna do that stock to leave once it lets me scroll down. Maybe you guys, whoever watches this, you can let me know if this is what you've been experiencing as well for the slowness in Fusion with practically everything. And then I'll know if it's a me problem or if it's a them problem. So there, we knocked that down another 0.5 millimeter. I want to do as little as possible because we're starting to affect the rigidity of these blocks, especially for the slitting operation. So I'm trying to find a balance here. Even if the tip was just dragging a tiny bit in the bottom of the channel, that's not going to hurt things. But I felt like it was a little too much the way it was. Of course, we don't want to drag the tip at all, but it's okay. So once this does its thing, I think I'm going to be pretty happy with the way this is programmed, and I'm actually going to try and machine them on the mill, and maybe I'll throw in some video at the end of how this turned out and if I had any issues. So here we go. This is 0.5 millimeter deeper, and then now let's see how it looks. So there we go. So we are now no longer dragging the tip. Now you can see we're taking a heavier chamfer here because we haven't done finishing yet. So we'll definitely hear the difference as the chamfer tool is running around. Once it gets to this point, it'll be taking a significantly heavier cut, as you can see. But I think this is good, and I think it's smart. I think this will give me a much nicer chamfer around here than with all of this material done first. And it didn't cost us a tool change. It just it really doesn't cost us anything at all in terms of time or production or efficiency or anything like that. So I think it's a reasonable change. So yeah, the next thing will be to actually run these on the mill and see how they turn out. I definitely have some concerns like this one final slot around the bottom here. That's a concern for me. The wall finish at this point back here as well is a concern, and we'll just have to see. We'll see what it does. One thing actually I'll do here, which I'm surprised it's actually, I could see why it's not a default. If we were roughing, like when I go to cut these out, you know, I thought when I was at this point, I thought to myself, well, I like using even step downs. To me, I like having them even. But where you're removing rigidity, I think it makes more sense to take the deeper cut first, and then maybe your second cut is much thinner because it's going to be a lot less rigid after you cut the giant slot out of it. So to me, it makes sense. But for this finishing, I'm going to want to use even step downs so that the surface finish is more consistent. So let's see what that does. Before it was, you know, taking like a 10 or 12 millimeter cut and then just the leftover. So I think this will be nicer. But anyway, this I'm a little concerned with how the finish will be on this and that one slot. But other than that, I mean, I'm expecting that this part will run quite well. So we're at like the 33-minute mark here, which is a lot longer than I thought it would be. Like most people literally watch these videos for like 3 minutes, and YouTube considers that like a great success. But yeah, hopefully this is somewhat useful, and I'll splice in maybe some video or pictures at the end of how these parts are going, or maybe some changes I have to make. I could do add in some more cam video, but I'm hoping that this kind of sheds some light on how you program parts on a fourth axis, and it's super easy, and it's been the best thing. I don't regret my decision at all to add the fourth axis to the machine. Any machine I ever order in the future will be at least fourth axis ready, because it's just so nice to be able to switch between all these different parts and all these different tombstones. It all uses the exact same work offset. I just one screw to remove the tombstone and switch to a totally different part, and I don't have to do any setup in the machine. No work offsets, none of that stuff. It's just all ready to rock based on the center point of the rotary where all my parts are programmed from. So it's just it's been amazing. So anyway, thanks, and like I said, hopefully you found this useful. All right, bye.